So, hello, this is Unit 9 of the NLP course. In this unit, we will first look at the homework, which will be for Unit 9. And then also in the first video, there will be a short example, well, not short, an example on how to solve this kind of homework. So it's about text classification, you will see in a second. Then there will be a second video about a bit more complex use case for also text classification, but with a really difficult data set for multi-label text classification in a different domain with legal data. So this is more for your information to see how to use fastAI in a state-of-the-art work for text classification. And then finally we will have a look in the third video of this unit at transformers, which are like the latest, not latest, in the last 2 years. They have been very popular in natural language processing and very successful. And we'll look at transformers like BERT and how to integrate those with fastAI. Good, then let's start with this first video with the homework. I think this is good as motivation for this example, which I then show you on how to solve such a homework. So the homework for Unit 9, it should not be too difficult. It's basically adopting given notebook to your use case. The goal is to do text classification in fastAI, and there will be different steps involved in this process as expected. First, you should just select a data set of your choice to do the text classification for and with. So you can choose any data set which you find on the web which has some text and labels to the text. So you need a text and labels. I would recommend a text that has only one label per text. There is also a multi-label text classification where you can have one or many labels per each text, but this makes it a bit more difficult. It's then the problem which we discuss in the next video. Or you can even, if you want, create your own classification data set where you have 2-3 classes of something and some examples for each class, maybe at least 20 examples if you want to do this by yourself. So that would be another option on how to do it. So first you select the data set, then step 2 you create a classifier and train it with fastAI. So there will be different steps involved. First you need to load your dataset from a CSV file or whatever it is. Probably you want to understand what's inside, or not just probably, you definitely want to understand what's in the dataset. So do some dataset exploration. And then maybe you need to clean it up a little bit to prepare it for loading in fastAI. Okay, once you've done it, you can load it as a fastAI data bunch and then start the training. There are 2 steps here. First fine-tuning the language model, and the second step is training the classifier. You will see in the example. And we also had the same steps in the last unit where I started to explain fastAI. And finally, you want to evaluate the quality of your model. So here you just want to maybe predict a couple of examples to see that it makes sense, and then you can do some analysis like creating a confusion matrix to see what mistakes were made and what worked in the classification. And if you want some bonus, so this is the basic homework, if you want some bonus points, then you could create a second notebook and just play around a little bit with the parameters like learning rate, number of epochs, maybe even using language model fine-tuning or not, just for you also to understand a little bit more in depth how this training in fastAI works, and understanding a little bit more about the whole process. So in the second notebook you could do some experiments with other settings, so this would be the bonus part for the homework. Okay, then let's look at this notebook, which will explain in this video. Okay, so this is a data set which I found. It's about spam detection. So it's a binary classification problem. You have a text, and the text is either spam, like a spam mail, or it's not spam, which is called ham. So in the data we have spam and ham as the labels of the text. So what do we do first? We want to understand the data set which we have, which is in this first part of the notebook. So first we just import the libraries, which is clear. Then here I'm downloading the data set in this cell. Okay, so it's just, I have had it somewhere in my GitHub repository. And then one first problem which I noticed was that the data set, it's in Latin 1 encoding, but by default at least fastAI expects UTF-8, the standard encoding nowadays for text. So probably this data set is also a little bit older. So first I just needed to change the encoding from Latin 1 into UTF-8 by just loading the data into a string and then saving it again as UTF-8 with this codex, Python codex. Okay, that was the first step. So this is just now cleaning up and understanding the data before we do the training, because if we don't do this, then we might have here unexpected results and not as good results as well. Then a second thing, now we have this UTF-8 spam dataset. So now let's have a look at it with pandas. So we just read it with the pandas library into a data frame, and then we just show the first 10 rows of the data frame. And we see that there are two columns which we expected, the label column and the column here it's called V2, the column with the text. But then there are 3 additional columns, and which are here, at least for the first 10 rows, they are all not a number, so they are really not defined. So I was a bit surprised what's going on here. Why are there 3 additional columns which we probably will not need? So then you can look at the data frame in some more detail with, for example, the describe method of the data frame. And there we saw that these 3 additional columns, they have in 50 instances, for example, the unnamed column 2, it has some values in there. But it's only about 1% of the total number of rows which have a value in this unnamed 2 column, and even less for the other ones. And there are some examples also, and we see that there is some text sometimes also in those columns. So I guess when creating or when loading this this dataset from the CSV file, just something with the segmentation or something with the separation of cells in some cases didn't go well. So what do we want? Either we could fix the and try to fix the loading with the CSV reading and fiddle around there to make it better so that everything is getting read into this column V2, or we can just now in the data frame try to fix this by combining those columns into one column. So the second thing is what I did. So then I did another method, dataframe.info, which also gives us similar information like describe in this for this. Then I showed a couple of examples where unnamed 2 column is set, so it's not null, not a number. So we see some examples of text in there. So okay, this is what we expected. There's 50 entries there. So what do we want to do? We want to combine everything from columns unnamed 2, 3 and 4 into the original text column, but only if there's some stuff in there. So I tried a couple of things. I don't need to go into all the details here. So in this cell here, I just fiddled around a little bit on how we could do this. And then the solution is basically here, which works. The other one weren't above, did not work properly as I wanted. So you can do something like you have the original text column, you concatenate the string of this with these three extra columns, which are renamed above into this extra 1, extra 2, extra 3, and with a separator of a space, so there will be a space between the text from the original column and the other columns. And yeah, and if there's a null value in the other columns, which is the usual case, then just replace this by an empty string, so that we don't get any fragments from these null values into the string. Okay, so with this yeah, command here, this statement basically solved this problem. And then I just printed some examples to see that it worked, and then finally took the column label and text from this data frame and continue just with this, because that's what we need. We need a label, we need a text. That's it. And then I just print it again with the head method, do some more describe to now see how it looks. So now we have the two columns. I'm still a bit surprised, or not surprised, but one thing so I also here in this video just wanted to show that cleaning up data is very important. So everybody who does data science probably has already heard about this. So one other thing which we now see here is that we have 5,500 rows, but only 5,169 are unique. So we have some duplicates in the data set, which doesn't really make sense. When we want to train this classifier, we don't want to train the same example multiple times in the same epoch. So we just want to remove the duplicates. And this is then which we do here in this call with this drop duplicates, and we say on which column are we looking for duplicates. The text column. For the labels we obviously want duplicates, we need it, but for the text we don't want duplicates. We keep the first one. If there are multiple, it doesn't really matter, and we do it in place. So we just yeah, we just make a new make a new data frame and remove those from in there. In place is false. That means we don't do it in place in the df clean data frame, but we return a new data frame which I then called data frame final, and this data frame final now has no duplicates. Okay, so then I save it to a CSV file just for the next time. Now we just have it. And then finally I made a couple of visualizations to look at the statistics inside the data frame. So the only thing which one thing which might be interesting here is how long are the strings in our text. So if you print with the text, so I took the text column or series in pandas out of this data frame and called the describe to see some statistics about the text in our data set. And we see that the average length of the text is is 82 characters. So this is very short. These are basically sentences. And maybe 25% of the texts are even shorter than 40 characters. So they're rather short sentences even. Okay, then the same information visualized. So this is just for each of the first 500 examples for classification, how long the texts are. So we can see most of the texts are somewhere between 50 and 200 characters. So yeah, not too long. And then another way of visualizing this information is to make a distribution plot, which we do here. And here from this plot we see So we have very many very short examples with around 40 or something like that characters in there, and then we have a second peak with maybe 150 characters. So this is also what we see here, that it's either the samples are around 50 or something, or they are around 150. So yeah, I don't know why, but this is the structure of this data set, and just it's good to know before we start the whole classification process. So okay, now we are finished with, not with everything, but just with looking at our data set and understanding it. So we did not train anything yet, but we will start now. And the first step is to fine-tune the language model. So we just set here the batch size. This, yeah. If you have out of memory errors when you train, just reduce your batch size. Okay, then for the language modeling, we just create this data bunch. So this is the fastAI specific thing. And now we create our data bunch. So this is important also for your project, how to create those data bunches for the training. So this is maybe the only it's not difficult thing, but where you have to maybe find out, yes, how is it done for your data set. So in our case, we have a CSV input dataset, which we called spam final CSV. So we can then use this text list. So we want to have a list of texts for our language model, and we say from CSV because we created from a CSV file. This is just the path where the stuff, where the spam final CSV is, and I just put it in the current directory. So this is just the current directory, and in there you have the file. And from that file, because now we want to train the language model, we don't need the labels, the spam and ham labels, we just want the text. So we can here say the columns we want is text. Then we split it into training and testing, just randomly with 10% validation or testing and 90% training. And we can give a seed, so to have it like every time we run it, we have the same initializations. And then we have, first we create it from CSV, then we say how do we want to split it, then we say how to label it. In this case we label it for a language model training, so we just give this, and then finally we can say create a data bunch out of this text. So this is the data bunch creation. If you have a different structure of your data set, you can either convert it somehow into a CSV file, or you can, there are many different methods in the fastAI API on how to load stuff. I think last time we saw something like loading from folders, so there's something from folder. If you have just folders with all your files in there, there is from regular expression if you want to define regular expression was probably rather for the labeling part, which we then have with the classifier. And there are different other things. You can load it directly from a data frame. So look at the fastAI library description if you have any different format than CSV, how to load the data. Okay, and once we've done that, then everything is pretty standard. We can save this created data language model. Then it's a save and load it, so we could just use it from here next time. Then there's the show batch method, which is important just to see what is now inside your data bunch. So now we have just the texts in there. And as we can see, and we have discussed in the last unit, fastAI does some pre-processing on the texts. So you can see there are some unknown tokens in there, because the vocabulary size, I think it's around 50,000 words, and if something is not in there, then it's replaced with these unknown tokens. Everything is lowercase, and so on. So there's some pre-processing done. And then we can create the learner, which now learns this new language model. And we base it on this LSTM language model, this pre-trained language model, which we now want to fine-tune with our data. So we use this pre-trained language model. I explained it last time, but this is very important to make. This is like was one of the big breakthroughs in the last years of natural language processing, to use pre-trained models, pre-trained on large data sets like Wikipedia, and then fine-tune it to your own corpus, so to get a better domain-specific language model. So we base it on this LSTM model trained on Wikipedia, and from this we create the learner. So this is our data, this is the original large language model, and this is some about dropouts. Yeah, it would go too far to go into details there. Okay, then once we have defined the learner, as you know, we always have to find a good learning rate. This is the only thing you have to do manually in fastAI, or you should do manually in fastAI. So we always call this learning rate finder method and then plot the results of the learning rate finder, and then in the graph we look for some area where there's a steep descent. So probably somewhere here at, what did I take, 5e to the minus 2. 5e to the minus 2 is probably here somewhere. So yeah, this seems like a reasonable choice for the learning rate. So it should not be at the very bottom, because we want to have a learning rate where the loss is still getting better. So somewhere where it's going down, like here. Okay, then we trained for 2 epochs and we got an accuracy of 30%. So in predicting the next word in the language model, already quite good. This was done on the frozen model, which is the default when you create the learner. Frozen model means only the last added layers, which we added in this learning learner definition, they were trained. And then in the second step, we usually want to train the whole language model, and for this we have to say unfreeze. We again want to see what is now a proper learning rate, now that we have a different model in a sense, because we unfroze it. And we get this graph. And here you see the lowest point is maybe at 3e2, e to the minus 2. So, but we don't want to be there, we want to be maybe power of 10 smaller. So yeah, I took 3 to the e minus 3, so somewhere here. That's learning rate, and then we train for a couple of epochs, maybe 5, and see that the results are getting better. So we are now at 33.5% accuracy in predicting the next word. And we can also see that we're definitely not underfitting anymore, because the training loss is much lower than the validation loss. So it's definitely time probably here to stop training, because validation loss is rather getting worse. So maybe one could also have stopped like here, where the validation loss is still quite okay. And yeah, but the accuracy is almost the same in all those steps. Good. Then now we have fine-tuned our language model. So we're done with the fine-tuning. We can save that model, and just for out of interest, we generate a couple of example sentences with this model. So we have a text that starts with by some, and then see which next words the language model automatically generates. Okay, let's look at the second one. Buy some food, mom called, buy 1 egg for me later. Okay, so yeah, it generates something that looks a little bit like English text. The issue is also that the training set itself, it's very short, and it's the spam messages there. Many of them are quite messy and no real good English language. So I think also this is why the language model which we get out of that doesn't produce such nice sentences. But it doesn't matter, it has to fit the problem which we have, and we'll see if it works just a little bit later, how well the classification will go. Good, so we have the language model, now we can start with the classification. So in the classification we have the same steps like with the language model training. First we create a data bunch, which is done here. It's almost the same. We create it from a CSV, from the same file. But the only thing is, which is important, we have to give the classifier the same vocabulary like the language model. So because we use the language model inside the classifier, so they need to have the same vocabulary, the same mapping of word to number and back, else it will not work. Then we split again into training and testing. And we now, but the only difference here, now we want to label this data bunch, and we want to label with the column 1. And column 1 was the label column in our data frame, or in our CSV file. So we want, with column 1 is the label with ham and spam. So we want to label our data frame with this column. And we create the data bunch. Yeah, that's it. Okay, then we save and load like always. Now we can have a look. That's very important to see if the creation of the data bunch, if it worked. We look at the show batch results, and we see we have the text and we have the target. Target is our the label, and it looks like, okay, we have text and target. Here all targets are ham, but this is just a coincidence. So if you have show another batch, then you probably get also some spam targets. Okay, looks fine. And we can already start with the training. So we can create a learner. For this we want to have a text classifier learner, which gets this data bunch which we just created. We give it as architecture, the same architecture that we used for the language model, this LSTM architecture. And now we want to use our language model which we trained before, and for this we load the encoder of the language model. So this is a crucial step here. So for making a representation of our texts, we want to use the encoder of the language model. And the encoder of the language model, it just feeds the words into the language model, or the embeddings of the words, and creates an internal representation for each text. And this is exactly what we need then to classify this representation into our classes. So we need to load this fine-tuned encoder from the language model. Good. Then we see here the architecture which is being used, which comes from the AWD LSTM model, which we have defined somewhere in the learner. Here we set which architecture which we want to have, and this is now shown here. Here it's even said AWD LSTM module with some layers, embeddings, and embedding dropout, and so on. But you don't need to really understand this. It's just the architecture of the network. If you want to understand it, well, you're very welcome. There are many resources on the web on these models. Okay. Good. So now we have the learner. Now we can start training. As always, we now want to find the best learning rate. So we call learning rate finder. And here now the graph, it looks a little bit more messy than before. What did I pick? 4 e to the minus 2. So somewhere here. Yeah, I think this makes sense. So you don't want to go to the bottom. Maybe even, yeah. Usually, one rule of thumb is from the lowest point, go back a factor of 10. Which we all more or less did, and we went somewhere here where it's going down steeply, 4 e to the minus 2. Okay, so then we learn for 2 cycles in this case, and we see that we already have a very good accuracy of 98.4%. So this problem is very simple. It's a quite simple data set of spam and ham emails. Maybe it was difficult 10 years ago, but now, as you see, even with like 8 seconds of training, so this is the whole training which we did on the classifier so far. We are already at 98.4% accuracy. But we can see that the training loss is still higher than the validation loss, so we can definitely train more, which we do in later steps a little bit further down. Okay, so this was the training on the last part, on the added layers of a network, and now again we want to unfreeze and this here step by step to then retrain our network step by step to get good results. So we can save this. In case we do something stupid later, we can just jump back to the first save point by loading this one. So now we unfreeze to the layer -2, so we are a little bit more unfrozen from the top. We again do the learning rate finding. Here it looks already so sometimes it's then a bit difficult to choose a learning rate. For example, in this learning rate landscape, what did I choose? 2e to the -3. So I chose something around here, which again makes sense. It's before the lowest point and it's going downwards, so it's also a little bit of just trying around which works. And maybe if you choose it too small, then probably there will be not much improvement. But if you choose a too large learning rate, then definitely your loss and everything will get much worse. So then you have to load your last save point, choose another learning rate and train again. Okay, now we're a little bit better, 98.8. Then we unfreeze to -3, do the same thing, look at the learning rate. So now again we have a different kind of landscape. Here I chose 1e to the -3, so somewhere here, yes, makes sense. Learn a little bit more. Here it even got worse, the accuracy from the last step, so this happens sometime, but yeah, it doesn't really matter, we just go on training. Or we could use a different learning rate here and train a little and try again, but I think, yeah, we also only trained for 1 epoch, so let's continue. So finally we unfreeze the whole network, or the whole model, the whole architecture, and again look for learning rates. Now the curve is a little bit easier to interpret. 5e to the -4, so I chose something around here. Yes, makes sense, it's going down, it's not at the minimum yet. And then train for 5 cycles. And we finally get to a result of the best one, seems to be this one. 99.2% correct predictions on this data set. And we could probably even still train some more, because the training loss is higher than the validation loss, so you could probably say learn for 10 epochs, maybe it would even get a little bit better. Good, so now the training is finished. We have our final model which we trained, and we want to evaluate the model. So first I just do some example predictions. So we have learn.predict some string, and we have some results which we get. Here it's like the category, and it also gives us the probabilities. So for this string it says with a 99% probability it's the model thinks that this is spam. And let's look first at this one. There is another sentence I gave it which should be not spam. Let's meet tomorrow and discuss the project. And here it says it's ham with almost more or less 100% certainty. The model thinks that this is not spam. And we can also see how long our predictions take. It takes with this model 145 milliseconds. So we could do about maybe 6 or 7 predictions in 1 second, which is not bad for So it's not really slow. It's fast enough for a normal use case. And then I think it's already the last stuff. We can look at the the confusion matrix, which you probably already saw somewhere what it is. So in the confusion matrix, we just compare the actual predictions or the actual values from data set with the predicted values. So and we see, as we see in almost all cases, the actual values are the same as the predicted values, which is the diagonal in this confusion matrix. We also see that there are many more ham examples in the data set than spam examples. So this is just the structure of the data set. And then finally we can see that there are like in 7 occasions, if something really was spam, it was predicted as ham. So here we have an error. Something that was spam was predicted as ham, and in 2 cases something that was ham was predicted as spam. So we see the kinds of errors. We can also print this error just like this with the most confused function. And we see the most confused was spam was spam. So really spam texts were classified or predicted as ham. So this and the other way around, which we have seen in the other box here. Then you could even look at the top losses. So here you can see the examples which created the worst predictions with the highest loss. So the example 958 had the highest loss, and I would just out of interest I wanted to see what is this example, so I printed the example here. So this is the example, test blah blah blah. So this text, it should be category spam, but it was predicted as ham. So now in the second line here I call the predict method on this text. So it was predicted as ham with 99.8% certainty. So it should be spam, but with a very high certainty it was predicted as ham by the model. So this is why for this example we have such a high loss. So this is the example with the highest loss. Okay, yeah, that's video 1 on text classification. So for your homework, just find the data set and do something similar. So most of the code you can just start with this notebook. You can just copy. You can also do it yourself. That's even better. But if you're lazy, you can copy the code. Even if you're not lazy, you can copy the code and then fiddle around with the code and just change the things that you need for your project, like which kind of data set you have, which format of the data set, the learning rates. Yeah, that's probably the most important things which you have to change. Okay, that's it. Thank you.